Hello friends, I am Dr. Saili Bhange and along with my associate colleagues Dr. Kiran Khandarkar, Dr. Jyoti Miskin and Dr. Sudhir Akulja, I am giving this presentation in OER on green chemistry. So green chemistry is the environmentally benign chemical synthesis which causes least pollution to the environment. Green chemistry is all about reducing the waste, materials, hazards, risk, energy as well as the cost. So why it is known as the green chemistry? Green is a strong, soothing color. It is the color of chlorophyll and also the color of money. Being green has long been a battle cry for environmental activists. It is a symbol of the green revolution as well as the green environment. And being green has become an important marketing tool for business making. It can be defined as the utilization of a set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture, and application of chemical products. There are 12 principles of green chemistry which are as follows. It is the prevention of waste, atom economy, less hazardous chemical synthesis, safer solvent and auxiliaries, energy efficiency, renewable feedstock, catalysis, safer chemical products, reducing the derivatives, designing for degradation, real-time analysis, and accident prevention. Moving towards the principles, the first principle is the prevention of waste. It is better to prevent the waste formation than to treat or clean up the waste after it has been created. Can you think of an example for this, for preventing the waste? Think about it for a moment and pause the video. So, the example for this is the eco-friendly plastics that can be obtained from corn waste as packaging materials. Also, the paper bags that we use nowadays are also an example for prevention of waste. Using rechargeable batteries rather than the primary batteries is also an example for waste formation prevention. The second principle is the atom economy. All reactants used should be converted into desired products, that is, the byproducts should be nil or as minimum as possible. Can you think of an example for this now? The acetaldehyde that can be manufactured from ethylene by using oxygen alone without any byproduct in presence of a catalyst instead of ethanol and sulfuric acid, which produces undesirable sulfates, is an example for atom economy. The third principle is the less hazardous chemical synthesis. Wherever possible, synthetic methods should be designed to use and generate substances that possess little or no toxicity to human health and the environment. Think about an example for this now and pause the video. The example for this is substituting yttrium for lead in auto paint or manufacturing secondary batteries other than nickel-cadmium battery. Fourth principle is designing safer chemicals. The chemical products should be designed such that they should be effective but least toxic. Can you think of an example where the substance is not toxic and effective as well? The use of DDT is banned and replaced by new safer germicides. So this is an example of designing the safer chemicals. Also, the use of nickel-cadmium batteries is discouraged and these are replaced by nickel metal hydride batteries or the lithium-ion batteries. The fifth principle is the safer solvents and auxiliaries. The use of auxiliary substances, example the solvents, separation agents, etc., should be made unnecessary wherever possible, and also if they are used, they should be made unharmful. An example for this is the alkylation of butene. The highly corrosive HF and H2SO4 were used. However, now these are replaced by solid acid catalysts like the zeolite, which is environmentally friendly. The sixth principle is the design for energy efficiency. Energy requirements of chemical processes should be minimized. If possible, the synthetic methods should be conducted at normal temperature and pressure. Can you think of an example for this now? Here, the example for that is the zeolites can be used as catalyst for cracking of petroleum oil, which requires a high temperature of around 450 degrees Celsius. So here the temperature and pressure required for cracking unit is dramatically reduced if we use zeolite as a catalyst. The use of renewable feedstock is the seventh principle. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practicable. Can you think of a renewable feedstock? The biodiesel is a renewable feedstock. It is also an excellent green fuel. The eighth principle is reducing the derivatives. Such steps which require additional reagents and can generate waste should be avoided. Manufacture of ibuprofen by conventional methods consisted of 6 steps. However, with a new process, it can be manufactured in 3 steps only. The ninth principle is use of catalyst. So, catalytic reagents should be used wherever possible because it will be a faster process. So, in this, if zeolites are used as catalyst for cracking the crude oil, that is petroleum, then the temperature and pressure required for cracking unit is dramatically reduced. The 10th principle is the design for degradation. Chemical products should be designed so that at the end of their function, they break down into innocuous, unharmful degradation products and do not persist in the environment. The example for this is biodegradable polymers like polylactic acid. The 11th principle is the real-time analysis for pollution prevention. Prior to the formation of hazardous substances, if unavoidable, analytical methods must be previously designed in anticipation. For example, the side effects of medicine are known even before its marketing and production on large scale. This may help in reducing the hazardous health effects. The 12th principle is inherently safer chemistry for accident prevention. Substances and the form of a substance used in chemical process should be chosen to minimize the potential for chemical accidents, including releases, explosions, and fires. The example for this is using green solvents like supercritical fluids and ionic fluids which are non-toxic, non-inflammable, and cost-effective should be used wherever possible. Then, in the next video, we'll see the use of these green chemistry principles in day-to-day life. Thank you.